So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 260 and in this video we continue with our virtual specifier and with the examples here on this page. We stopped in our last video with this example and now we continue here, and it says here in the introduction sentence, if a function has more than one final override, the program is ill-formed. So let's see, what does this mean? So it starts here again with an example. We have a base, this is called struct A, it has a virtual function, it's called f, and then we have a derived class called VB1, and then it's a virtual A. Again, don't mix this virtual with this one. This virtual has another meaning than this with a function. And here again, a reminder, it looks like a normal function, but this one is actually a virtual function and has override here invisible, right? We have to know this, but again, best practice is just write override here so that when we watch this function that we know it is overridden from the parent or somewhere else. All right, then let's go on, and then we see we create here another struct, another virtual A. Again, this one is again a virtual function. It's not there, and it's an override. You can see overrides AF or AF. Important here is we inherit here virtual A and virtual A. We learned what does this mean. This both structs share one base A later if the compiler constructs them, and this can cause a problem. What is the problem? Because they share only one A, so they have only one A, and they have here two different overrides, right? The compiler says, okay, which one I should take as the final override, this one, and this is the problem, and that's why it is said it is ill-formed. Ill-formed means it will give a compiler error, and you can see this here in this example, which is a comment. They tried to create a struct, then they tried to inherit from this one and this one, which shares one A. And then you can see here in this comment what they say. It says error AF because has two final overrides, because the compiler tries to figure out, should I take this override or should I take this override? That's the problem. But interesting is what happens when we continue, and this is not so intuitive, because many would think now, because this is not possible, then this will be solved here differently, right? But look what happens. This is not very intuitive. When we create here another struct, they made it, and here they inherit again VB1, VB2, like this example here. When you compare it, this one and this one look similar. Only the name is here different, but here they provide another override, and now this becomes not ill-formed, also which means the compiler will not complain. This is valid. Even we have here two overrides in virtual A, which cause normally a problem. And the point here is you have to be careful when you're creating something like this one, because here this in this example here, you can see they provide again an override. You can see it's again, it says again not virtual, not override, but this one is overriding all. It starts from here, it goes here, here, and then it's overriding here. The compiler knows this is the final override, which means when we call a function, this virtual function, it will choose this one in this case here. And that's why it's okay. And this is not so intuitive, because we would think, wait a minute, if this is already not allowed, like here, why they continue? Yeah, this is, you have to understand this and as an exception, because yeah, it's not so intuitive, I would say, for beginners and in general. Okay, let's continue. And then it says here struct VB, so we create again a new struct. Again, we are inheriting from a virtual. You can see we have now one virtual, two virtuals, three virtual. They are sharing now all these ones share A. So they are creating one A as the constructor is creating here one A, and they are all sharing their functions and so. And here it says now, let's see what it says here. does not declare an override. Yes, we see it. It's not here, because if it would declare an override, that would be something like this. And what happens then is, if it's not declaring override, but the question is, why is this okay? Again, this one is inheriting from A directly like normal. And when we have this one, it will just use, which one would use this in this case when we call, for example, this F? What is here called? What do you think? It is called this A virtual void F, because it's not providing an override, right? You can't see it, I hope. And if not, just test it like all time. When you can't see something, just put it in the compiler and follow those, make a test like all time. So here is no override. Override means here in this case in the body is no override. It will call this one. Let's continue. And then it says here struct A. Let's see what it's creating here. Inherit from VB1, VB2. This is this one again. Again, we like this other one here, similar to this one. And then it says here in the final override AF is BF2. Yes, we learned this. Why we learned this one here? That this is the final override. Let's check this out. So we can here, VB1 is which one? It's here. And this one is not providing an override, which means we don't consider this here. Then VB2, yes, here we have provided an override. And here, when we call this one, anyhow, it will be called, this is a final override. And again, it's not so intuitive because this one, because normally we would say, okay, we have here an override, and they are virtual. Oh, they share, that will cause a conflict, right? But you have to learn it. It still works when it continues and you learn this rule here. You have to test this a little bit, try to understand this, and again, the best way is to watch this again on online resources, a good C++ book, because this is just a little bit faster overview. Let's go on and go to the next example as well, because these are just examples here. And here it says a function with the same name. Okay, we are working all time with the same name here, but different parameter list, which means here is an example with the same name. We have the same name F, but we have a different parameter list here. The list does not override a base function of the same name, which means if I have this one here, it will not considered to override this one, which means when we call this virtual function, this will be not considered, just so. And then, but hides it. So hiding means most time it is not accessible or it is not considered. That was wrong. Accessibility is something else, but not considered. Then when unqualified name lookup, we have not talked about this unqualified name lookup, but it is just when the compiler tries to search in this lookup here, examines the scope of the derived class. The lookup finds the declaration and does not examine the base class. We will see what this means now in these examples. So what it means, the lookup finds the declaration. Let's get started. Okay, we start here. We have again a struct B, our base, and again initial word virtual, where this virtual must be one time declared where the start point is. So it is here, our start point is here. Again, this one is no override because we have not a name. Okay, and you can see here df hides bf. It is hiding because that was the new rule. It is hiding this one. Wrong parameter list because it is considered not the same. Okay, so far so okay. Let's go to the next. We create another struct. We inherit from D, which from here. And it says here void f, but careful. This void f is not the same like here. Again, we have here a different parameter, but this void f here is the same like here, which means this one is an override of this one, and you can see df, d2f here overrides bf, and bf is here. Free bf is here. So we are overriding the base with this one. Even we are inheriting from D here, and here is not this function. That's the which is not considered. So that is the thing what you have to keep here in mind. it is going here up to B and overriding it here as a final override. And it says here in the comment, oops, you can see it doesn't matter, that is not visible. And visibility means here, because normally this one goes first to B, to D, sorry, here. And here is not this function, but then it goes again up, and then it finds this one, and then it says, okay, that was the initial, there was no other override till now, and I defined a new override. Okay, then let's see if we try to understand these examples here fast. So here you can read this a little bit on your own. They are creating objects, and here this naming is a little bit strange, so that I try to explain here a little bit. So this one is just a reference to B, but what means here BSB? This naming, they try to indicate it. They say we make a B object, this is B, SB, and we are referring, because we have here a reference to B. Let's try to go to the D as well. So we start with creating a D object. So we are creating this one here, an object, we call it D, okay, and then B reference DSB. What means DSB? Our D here, that one, this D here is our reference, you can see it, will be considered as a B. And why? What was here the rule? We have not talked this in depth, just then I will not talk it in depth now. There is an implicit conversion, which means this D here, struct D, will upcast to B. Here in this case, this D becomes a B, and that's why it says here DSB. So this D will be treated as a B, just so for naming a little bit. It's strange to explain. And yeah, you can read this now a little bit more, and that goes so on. Then they create here D2, for example. Here you can see they create here D2 object, and then they refer from B, for example, from B. And then again here this D2SB, which means we start from D2. With this one will upcast to B. That Y is called here D2SB. So this one becomes B. This D2 becomes D. And watch this a little bit on your own and try to understand this. And I go here to these little examples. And it says here BSB, which means, let's see what this means. We have here B. It's pointing to a B, which means you can see we have here B. And then we create a B reference again to B. So we are going to in, and then when we call this F here, it stays here. So you can see call BF, you can see it stays at the same point because there is nothing to call other. And then interesting is more this example, it says here DSB. Let's go here again. D is here and B is here, which means this D was upcasted to B. And let's see what happens here. And if we try to call F, and here it starts with this because it was upcasted, F, and it says, yes, we call F here again. All right, so far so nice. Let's go here one more step. D2SB, again the same scheme. It starts here D2, it is upcasted to B, all right. And then we call F, which means here we call F, it starts here. And interesting is, what is now? What happens now? What do you think now? Is it this one here? It was, let's repeat, I repeat. It was here, it was upcasted here. It starts with this one, but now it finds this and it finds an override. That's very important. Here in D we could not find an override because we just learned different parameter are not considered as an override. But here we have no different parameter. This is exactly this one. That one, that's why we have here an override, and you can see here is D2 of F, not like the other ones here. And now we watch a little bit the special cases here. What is that? D, SD, and then we call F. Why here is an error? It says here lookup in D finds only F int. But let's watch this again a little bit detail. We have created a D object, we referred to a D object, and there is no F, right? You can see there is no F in this case. even we have inherit this one publicly. Important is you don't have to forget this one is an inheritance public, which means normally we see this. You have to test this in code again. When you make an object, you see this function here, but this one hides this one here, and this one will be considered, and that's why here we have an error. This is this hiding, and the same goes for the other one, d2 sd. So again, we have here d2, this one is sd, here this upcast, and here it tries to call f, but important is it goes here and it finds not f. There is no f. Again, why not? Normally it sees this one here because again it's public all, but this one again the rule says I hide this one so you don't see it. Error. All right, this is not so easy, this kind of stuff. Don't worry if you don't understand it right now. You have to test this on your own, play around a little bit, and try to understand this so in your own way. So let's go here to the other ones too. They are not so big things. They are very fast. And then we finished here these little examples. Here it says if a function is declared with a specifier override but does not override a virtual function, the program is ill-formed. Ill-formed means all time, not compiles not, and cause problems. So it says here we create a struct B. You can see there is no inheritance, which means it's just a base class. And we have of course our function, which is a virtual. And we have here int this time as a virtual function with parameter. Okay, then we create here a struct, we inherit it. Again, the B1, that's normal. And we have here indeed an override. You can see this one here is when you are not omitting. This one is all time here. For example, in this other examples here, let me show this one. For example, here, this version is like, normally it looks like this one. There is a virtual, there is a override, but you can omit this kind of stuff. So you can see this one, they are just using here the full style, I would say. And this one is normally the best for beginners because it's all time showing what it is. Anyway, we have here virtual, we have here void, we have here the same function name, and we have override indication. We know it is indicate this is a virtual function, and it says here, okay, df int override bf int. This is this thing what we learned, but here we try to use the word override, and that was what I mentioned you. If you use the override here in one of my other videos, I said if you use override, you have to provide a virtual function, and here is not a virtual function provided. This looks same, it's not. The parameter list is important. So with other words, to make this accessible, you have to write here virtual void f long here in the base as well, without override. This override you don't write in the base because this is your start point. All right, so if you write override, you have to provide here something to override. But other way around, that was what I said with the other way around. If you have here something provided, you can omit, for example, this one, and you have to know that, and you can even omit this one here, and the compiler will consider this still as an override. That's very important. That was this one rule where I said other way around is not working, but I hope you understand this. Try and play with this again to omit this and see if this works. And then here, if a function is declared with a specific final, specifier final. We have not talked about this final in depth. It's just a little mention here. We will talk perhaps later more. And another function attempts to override it. The program is ill-formed, which means you can define the end destination. I told you in one of my videos, the compiler starts from top. For example, we have here different functions. The compiler sees this first, then it notes here in the virtual table this is your first, and then if it finds other overrides, then it is going to the final override, which is finds, which means if it finds no other overrides, it becomes automatically final. For example, in this case we have here this becomes final when I call it from here, for example. But we can change this. For example, if you write final in this other example here on top, if I would write, I don't know, anywhere here, let's say this one here has one more, or let's go here, let's say here, we have here one more, let's say without this one here, and I wrote final in between, or let's write here final, and let's say here is one more, then this one would be not considered. You understand it probably. Final means just don't go and search more. Like in this example here, we have here virtual void f const final, which means I can write it even with base class, which means if you try to inherit from this one, it's not allowed. Even it fulfills all the requirements. You can see it's the same name, it's has all this kind. This one is not considered to be used. All right, that's very important here. Let's see what we have. Non-member function and static member function cannot be virtual. All right, non-member function and statics, very important that they are not. With this kind of stuff, you have to make some examples. Let's go here a little bit more. Function templates. Okay, we have not talked about function templates. Let's skip this. Here it says virtual function whether declared virtual or override one cannot we have associated constraints. We have also not talked about constraints. Constraints, you can see, is this example here. We have here a function, and then you can even try to see if this has a very specific behavior, but we have not talked about these constraints. We will talk about these constraints in another video. I think that's it for these examples, and we have to talk about this covariant return type. That was the return type where I made an example here on top where I said you can have a different return type, right? We have seen all time the same return type, but careful, the return type can be different. This one can't be different. The name, the function name, the parameter list, this can't be not different, but the return type can't be different. And here we talked about this requirement, and it says here, but not the return type. And this return type has a specific requirement, and this specific requirement is this so-called covariant return types, and this one we are talking in our next video a little bit. All right, I hope you understand all. I don't think so. That's why I try to watch online again. Resources, good C++ books, and train this a little bit, because there are things it's not so natural. In general, not super difficult, but yeah, this little detail rules should be can be annoying, because you have to at least know them if there is a bug, because that's the biggest problem of a programmer. We have to find later bugs in programs. And this little kind of things can cause bugs when we don't know them. All right. With that said, if you have any questions or anything else, write in the comment section. See you in the next video, and like all time, have fun and never give up. Bye.